Okay, I know we already have a lot of questions about this lab assignment that's coming up. I am gonna take a little time this morning to discuss it. So you know is spectroscopy, right? I know you reading should help you get a good idea. And let's talk about spectroscopy a little now, just to cover the basics. What is spectroscopy? Well, the simplest definition I can give you is that the spectroscopy is a study of interaction between matter and light. Now, visual light consists of different color or wavelengths, which together make up what's called a spectrum. Amount of colors like you see in the rainbow, and all substances, all from the matter, can be distinguished according to what wavelengths and light they absorb and which ones they reflect. It's like environment has what we call its own spectral signature. If we can really focus on identification, and that's exactly what spectroscopy does. Now, laser spectroscopy, which is a focus of your assignment, works by measuring very precisely what parts of the spectrum are absorbed by different substances. And it has application in different disciplines, and your assignment will be to choose a discipline that interests you and devise an experiment. For example, I'm going to talk about I'm interested in a spectral use analyzer. Let's say a museum curator comes to you with a problem. She's come across with a painting that appears to be an original, let's say a Rembrandt. And she wants to acquire it for her museum, but she's got a problem. She's not absolutely certain it's an original. So what do you do? How do you determine whether the painting is authentic? Okay, think about the scientific process. You've got the question, is the painting a Rembrandt? So first, you need to make a list of characteristics the painting would have to be a Rembrandt. Then you have to discover whether the painting in question has those characteristics. So first of all, you need to know the techniques Rembrandt used when he applied paint to canvas, his brushstrokes, how secretly he applied his paint. So you need to work with an art historian who has expert knowledge of Rembrandt's style. You have to know when he created his paintings, what pigment he used, and as well as what ingredient he used to make different colors of paint, because ingredients used in paint and binding agents, present finishes that you have changed over time. Since you're trying to verify that the Rembrandt, the ingredient in the pigments will need to have been used during Rembrandt lifetime in the 17th century, and that's where chemistry comes in. You have got to find out what's in the pigment, run the composition, and that requires lab work, detective work, really. In a word, spectroscopy. So how do we use spectroscopy? Well, we put an infrared microscope, a spectroscope, on tiny bits of paint, and using ultraviolet light, we compare the signature of those particular elements to determine what the pair made of. So you can see why this type of analysis requires a knowledge of the history of pigments, right? How and when they are made. Say we determine the pigment was made in zinc, for example. We know the spectral signature of zinc and it matches that of the paint sample. We also know that zinc wasn't discovered until the 18th century. And since Rembrandt lived during the 17th century, we know he could have painted this. Now, spectroscopy has a very distinct advantage over previous method of analyzing light because it's not invasive. Analysis features what is required. All you do is train the mics for tiny frames. Now, while about restoration, sometimes original artworks appear questionable or inauthentic because they will have so many said touch breaks to the recover when they are fried. Then, if we redo bad restoration time, so we can determine what kind of process we can use to remove them to dissolve the paint and cover the original.